So what is the application? Since we spent all this time deriving these results, we should have some application in mind. So for B to C U bar D, this, if you ask about what process that gives, well, one process that it gives is just a B to D pi transition. B bar is built of U bar B, and this guy's U bar C, and the pion is the U bar D. So we can think of the reason we're studying this is maybe we want to calculate B to D pi. So if we wanted to calculate B to D pi, we take matrix elements involving our Hamiltonian with a B meson in the in state and a D pi in the out state. And if we just use the original Hamiltonian that we wrote down without the renormalization group improvement, then we would have that. That's without renormalization group improvement. So this is at mu equals mw. And the problem with this formula is that this matrix element has large logs. It depends on mw. It also depends on mb. And if it's something we can't calculate, then that's kind of bad news. In particular, having large logs like that would also make it hard to calculate something like this on the lattice. So it's not just it's really a problem. If you have multiple scales tied together, it just makes the calculations harder. It's also a problem for dimensional analysis, because if you have large logs, that means you've got large numbers, and something that you thought was of a certain size might be bigger or smaller. So what we do is instead we work in the renormalization group improved version, where we take this down at the scale mb. So this guy includes the renormalization group evolution. We use our results over there. And then we've got the operators at the scale mb, and there's no large logs. Okay, so you'd want to calculate something like this on the lattice or some other way. There's other ways of doing it. And we'll talk about other ways of doing it later on. But so far, we've separated out the scale mw into this coefficient that's evaluated at the scale mu equals mb. Okay, so the one way of thinking about this is if you want to do physics at the scale mb, the right couplings to use in your theory are these ones. Forget about what's going on at the high scale. You have to determine the low energy couplings that are appropriate to the theory you're dealing with, and those are these C's at mb. Okay? All right.